Hello everyone. I'm going to give you offer related to CCIE lab. In this lab, what you will find, so let me quickly show you that. In this lab, you have multiples switches. You can see you have more than 16 switches, 20 routers. You have SD-WAN full-fledged lab. Actually, this is complete CCIE enterprise 1.0 lab, where you can do section 1, section 2, section 3. Maybe you know that in CCIE exam, you have 3 different sections. Means already sections are defined, but generally these 3 sections that students are practicing. And in this 3 sections, you can perform everything, all the tasks you can perform in this particular EVE-NG lab. You can see the version and the supported images. This is exact match that we have in the exam as well. So for example, for SD-WAN, you need to work on vEdges and the vManage. Release is 18.4. That's the same release we have in the exam as well. So this will be your very much similar lab setup that you have in your CCIE exam for your practice purpose. Now, what you can't do in this lab, you can't do lab related to DNA because in this EVE-NG lab, we don't have Cisco DNA integration, and you can't do ICE lab as well because in this we don't have ICE integration as well. For that practice, you need full-fledged online rake from any good place. You can go and have it. But apart from that, apart from 2.1, 2.2, actually, you can go and perform all the tasks. Even if you are not practicing for your CCIE exam, for example, you are practicing for your CCNP and you want to check your OSPF knowledge, BGP knowledge, MPLS knowledge, SD-WAN knowledge, all those tasks you can go and perform in this lab. With this lab, I'm providing the video guide how to do all those tasks. Even we have the lab guide as well. So you can simply follow those guide. You can simply go and complete all those tasks. Suppose if you are new to the technology, so I have multiple free videos in YouTube and Udemy that you can go and refer to upskill your knowledge, to learn the technology, and then simply you can go and use this particular lab and you can break any CCNP, CCIE exam. Means you will pass it easily. Now, what is the cost? And these are the sections that we have in the CCIE exam. So what is the cost of this? Because I'm offering this for the students, so I put very little a small cost here. So you have to pay only 150 USD to get this particular software. And how you can go and get it, you have to email me. So my email address, you can send me one email request. Let me write here, Ratnesh721 Kumar 721 @gmail.com. Just email me and send me the request, and I will give you this particular nice software, full-fledged software, EVE-NG software, or the file where you can go and practice your CCNA, CCNP, CCIE, SD-WAN, full-fledged SD-WAN is there. So if you can go and watch my YouTube videos, in YouTube I have 22 hours SD-WAN video recording file and so many SD-WAN videos I have uploaded in YouTube. Those YouTube videos also you need some lab setup, right, to practice. So even if you're not preparing for your CCNP or CCIE, simply you want to learn Cisco SD-WAN, you can go watch my free videos in YouTube, use this particular lab setup, and you can perform your SD-WAN. You can become master in the SD-WAN. Likewise, if you're preparing for CCNP, in CCNP, again, we know that we have N core and one elective. For that also, you can go and perform all the tasks related to routing and switching, OSPF, BGP, everything in this lab. It's a full-fledged lab. So I will recommend you to send this email right away. Take this particular lab, practice, enhance your skill, and become very good in the market so you will get high paid salaries. All right. After that, you go and watch the technology video. Thanks for watching. Thanks for joining. We are in day number 9 of CCIE design. Today, we are going to learn about wireless principles and wireless design. I have shared one video in the WhatsApp chat. You please watch that, at least 3 hours of that video recording. Uh, Once you watch that 3 hour of recording, you have very good understanding about basics of wireless. And then after that, once you watch this particular video, then it will be very much clear that how wireless network is working, what is a wireless. Uh, Actually, in wireless, two components are there, the data plane and the control plane. So what will be the control plane high availability and redundancy principle? Okay. In this session also, I will try to make sure that you will understand the wireless concept. But whenever you are learning new technology, it's like a long going process. Means it's not that in a single shot you will understand everything. You have to keep watch it, do some hands-on practice, and then watch it and do practice and work in your workplace. Like that, it is taking some time to learn new technology. But the key here is that keep working, keep try to learn, understand, then you will understand this any technology. When I started learning VMware, it was very difficult for me to learn VMware because it was very difficult to understand this port group and features of port group. And as a network engineer in Cisco or any networking domain, we are very much uh, prone to know. Means if we if we see some physical box, some cables, connections, interfaces, so we are understanding those things. Okay, physically it is connected here, physically it is going from switch to router, router to firewall, like that. But in VMware, everything is virtual. You have virtual NIC, you have virtual connections, you have kernels, like that. You have to some sort of translate that physical thing to the virtual thing. Likewise, when you are learning this wireless, in wireless also we don't have interfaces going from one AP to controllers, controllers to switch and all. Wireless is something that you have wireless frequencies, different type of frequency, or they are telling that a spectrum. In that, maybe you have 5 gigahertz or 2.4 gigahertz frequency. You have single band, dual band, different type of antennas are there. Like it's very different type of domain, this wireless world. So in that wireless world, you have to go and somehow figure out that how the data is moving from one place to other place without wire, right? And that is actually very interesting. So we know that in our normal IP packet, we have some payload, we have uh, MAC headers, we have IP headers, we have some TCP, UDP headers, etc. And then either those packets using TCP protocol or UDP protocol to send or receive, means source and destination, they are using these protocols to send or receive the packets or files. Like that, it is happening in the wired network. But in wireless, things are different. And in wireless, if you go and check the packet header size, it is bigger than normal Ethernet packet header. Okay. And even their mechanism is also different. That's why if you watch that 3 hour video, I have covered these small topics, that how the framing is happening in wireless network, then how the framing is happening in the wired network. In your CCIE exam, you will not get any question related to wireless technology or WLC. But if you go and write your CCIE wireless, then you will get all these things, all these topics, configuring WLCs. Different type of WLCs are there. One is legacy WLC, WLC is nothing but wireless controllers, and one is the iOS XE based controllers. The two controllers are there in the market at the moment from Cisco, and now Cisco is trying to convert all the controllers as a iOS XE based controllers. Now, when we are talking about iOS XE based controllers, that means their configuration is very much like normal Cisco iOS XE based routers or switches. Okay. Now, before going there, I'll make one thing easy for you. So in previous session, we have discussed about SDN, software defined networking. You know that SDN is nothing but decoupling of control plane and data plane. And is it SDN new term or new thing? So SDN is not new because WLC, wireless LAN controllers, they are using this control plane and data plane concepts from years, maybe 15, 20 years. They are using the concepts of SDN. So what does it mean? It means that if you have full-fledged wireless network, let me show you the diagram. You can see here in the diagram that you have access point. So let me highlight here. You can see that you have access point, and you can see that you have controller. Now within access point to controller, the communication is happening in between CAPWAP tunnel. This is the tunnel, and you will see that CAPWAP, see the control and provisioning wireless access point. This CAPWAP carries control and data traffic between the two. So control plane. Now you will see that you have in this CAPWAP tunnel, you have two different type of tunnels. One is control plane tunnel and one is the data plane tunnel. And if you know this concept of SDN, and if you know a little bit about the Cisco SD-WAN, for example, and we know from Cisco SD-WAN that you have vSmart, vBond, vManage, and then you have VH devices. So suppose you have vSmart, vBond, vManage. They are the controllers. This is for control plane. This is for orchestration. This is for management. And suppose if you have VH1, VH2, so you will find then that in SD-WAN term, the tunnel between the VH to VH is IPsec tunnel, that is data plane tunnel, and tunnel between the edge devices to the controllers or in between the controllers, they are control plane tunnel. They are nothing but the DTLS or TLS. These are different tunnels. This is control plane tunnel, and in below you can see this is data plane tunnel. So the term that we are using in SDN now, it was used long back in wireless network, long back, right? Now you can see that this is the new term that we are learning, and we have sessions for SD-WAN. Later on, we'll understand more about this. But point I want to make here is this, that when we are talking about this wireless network, so we have this concept of control plane and data plane, right? So now data plane. You can see this data plane, DTLS, and control plane encrypted. So it's still in SD-WAN also we have DTLS control plane tunnel, but in SD-WAN we have IPsec data plane tunnel. In wireless they are using DTLS tunnel. Okay, so up to this point you have any question? Okay, no question because maybe you haven't worked on wireless much. But you should know at least basics of these components because maybe you are seeing that someone is handling the Cisco Prime, Cisco DNA, WLC. Cisco DNA is one of the product that after this class, you should be mastering on this. Because in our lab exam, we have questions related to Cisco DNA and Cisco SD-WAN. So not only you should be very good in normal routing switching like OSPF, BGP, EIGRP, but you should be very good in DNA and SD-WAN after this class. Okay, so now let's try to understand this wireless principle. You can see the components of wireless. We have one controller. So when we are talking about controller, what this controller will do? No brainer. From controller, you can go and configure the devices. You can create the templates. You can create the SSID. You can create the SSID profiles. You can go and create all sort of configuration, right? And then WLC will go and push those configuration to where? It will go and push those configuration to access points. You can see different access points, right? Now, in this diagram, this is actually a very good diagram. You will see all the components. So one component, who is the controller here? Controller is WLC. So you will see that you have controllers here. Now, in this diagram, you can see that we have two controllers. Why? Because you can go and create the high availability and redundancy in between the controllers. So suppose if it is a big infra, and you will not rely on one single WLC, right? Suppose if one single WLC will have some issue like it got rebooted or it got crashed, etc., then you should have two WLCs in the redundancy. So that's why you can see we have two WLC here shown in the diagram. And then you can see that different access point at different locations. Then, so second component is AP. AP is nothing but you can think as access switches, like it is near to the users. So users, they will go and connect with the AP. Now these APs, they have some sort of SSID. Maybe you don't know about this SSID, but every day we are using some sort of SSID. Now if I go and open my laptop, you can see this wireless connection is there. If I go and click here, you can see that one SSID. This SSID is nothing but the wireless network. So this wireless frequency I'm connected with. Apart from that, you can see one other as well, Airtel. Like that, if you go and check in your enterprise, means in your company, you can see different type of SSID or wireless network, such as protected LAN, internet, Wi-Fi. Like that, in company they have different for different purposes. Even in your home as well, if you go and check, click there to that wireless icon, you may see 10-15 different type of network that is received by the laptop. So that means this handheld devices or laptop, they are working as a receiver, right? So they have something called wireless NIC card. We have physical NIC card as well, right? Where we are connecting the RJ45 connection. But now in the modern laptops, like in the modern devices, you don't have that connector, RJ45 connector, although you can use some sort of converter, C to RJ45 converters. So what we have, you have something called wireless NIC. Those wireless NICs are nothing but some sort of receiving antenna. They are receiving the frequencies, right? That means that nearby APs, so whatever AP we have in our room, these APs, they are broadcasting. So they are sending some broadcasted network, and then these systems, they can go and receive that. So this is the sender antenna and this is the receiver antenna, and you can go and connect that particular frequency in your laptop or in your mobile. But the point here is this, that these are secured medium. So you have to put some SSI, you have to go and put some sort of key, pre-shared key, to connect with these frequencies. Once you connect, then you will get the network. You will get the IP as well, because they can work as a DHCP server, DNS servers as well. So you can get some DNS information, you can get some DHCP IP, you are connected to that network, and then you can go and connect to the rest of the world, right? So that is very important. Whatever we are doing in the LAN network, you can do this in the wireless network as well. And we are talking about different type of components. Cisco has introduced one very popular component that is called as Cisco Prime. PI is Prime Infrastructure. You can see this Prime dashboard. This is Cisco Prime dashboard. And now Cisco has another very popular product, that is DNA, DNAC, Cisco Digital Network Architecture. This is just a marketing name. The original name is Epic EM, but now Cisco has rebranded that Epic EM to DNAC, Cisco DNA. This is very, very popular because now I'm getting good amount of projects related to DNA. So earlier it was not that popular. So Cisco used to send their DNA box. This is actually a UCS C series big servers, where you can go and plug these servers as a management plane, and then it will discover everything, and from there you can go and manage the entire wired and wireless network. Right. So what Cisco has done, that slowly they have moved their prime infrastructure to DNA, and slowly they are stopping this Cisco Prime infra or Cisco Prime hardware and software. It may be software, it may be hardware. And now they are moving everything to the DNA. So suppose actually this is Prime dashboard, but Cisco is moving Prime to DNA, because DNA having so many different capabilities. You can do good amount of work from DNA, and Cisco is adding new features like every 2-3 months inside the DNA. Apart from that, you can see this wireless component. We have this mobility service engine, MSE, or Cisco Mobility Exchange, or something, Experience, or something, CMX. This is basically related to wireless mobility, that you don't need some sort of full-fledged controllers, but you can go and install such type of mobility devices in a cluster that will provide you good amount of roaming capability, like that. Again, this is purely wireless terminology. So these are the wireless components. You have WLCs. Why you have WLCs? Because WLCs, they are nothing but the control plane, and from WLC you can go and configure, or you can manage good amount of access points. Now at this point of time, you may think that we have WLC, we have AP, why we need DNA? Now DNA also you can go and discover the WLCs, and DNA can work as a prime controller for all the IPs. That means in DNA, you can go and create the profiles, you can go and create the configurations for WLCs, and from DNA itself, you can go and manage all the WLCs and AP. Okay, so DNA can work as your prime management plane for everything in your network, wired and wireless. Now, what's the principle? Let's see the principle. AP must have CAPWAP connectivity with WLC, means you should have the control plane and data plane tunnel. Then configuration download to AP by WLC. Who is the controller? WLC. So WLC can configure everything and AP will go and download all those configuration. All Wi-Fi traffic is forwarded to WLC. That's right. The control plane traffic will go and forward it to WLC. Now this is the principle of wireless networking, and these are the components. In DNA part, I will go and cover a little bit more about wireless and how to configure WLC, discover WLC and configure WLC from DNA. That I will cover in DNA. Okay. So let's continue this discussion. We have 10-15 slides related to this. What is CAPWAP tunnel? Again, I suggest you to watch that recording. I have covered these basic things in that particular recording. We need CAPWAP tunnel, this secure tunnel in between the APs and the controllers. And we have two types of tunnel you can see mentioned here, control plane and data plane. So in between this, all the matches exchange is happening. And this diagram is actually very interesting. You can see that first you have this CAPWAP tunnel, right? And then only the Wi-Fi client is able to reach to the business applications. Now let's try to understand this CAPWAP state machine. This is again just for the knowledge purpose. AP boots up. And AP, if you work on any of the Cisco AP, they are very fast. You can go and reboot AP and it will come online within 1 minute. Not like routers or switches, it is taking time to boot up and come back online. APs will come, I think within 30 seconds also it will boot up and it will come online. So once AP will boot up, then it will try to discover the WLC. So what we are doing, we are configuring everything in the WLC. Obviously, these APs need connectivity to WLC because once AP boot, they should get some IP. They should know how to reach to WLC, because if they do not reach to WLC, obviously they will not get anything. So they are discovering the WLC, then this DTLS setup, with whom this DTLS setup will happen, obviously with the WLC. Then they will go and connect to the WLC. Once they are getting connected to the WLC, then they can get the image, then they can get the config, and then they will work. Right? Now, this is very much the process that you will know this particular process in the upcoming session as well, because this is very much ZTP or PNP. Oops. Plug and play, right? What you are expecting in plug and play. In future, in SD-WAN, we have one lab related to ZTP, zero touch provisioning. That means you can go to any of the branch. You can go and connect the V edge or C edge router to the ISP. At the moment, you'll go and connect those edge devices to the branch, to the ISP. They will go and automatically get the configuration, get the image, and they will join the fabric. Joining means joining the fabric, joining the SD-WAN fabric. So here also you will see it's like 100% same thing. This is a ZTP process that once you boot up, think this is this as a switch. So once you go and boot up the switch, they will start discovering the the management plane, the controllers, VSmart, the VBonds. So they will start discovering the controllers. Once they discover the controller, they will also go and form the DTLS connection. And then they will start to join the fabric. But since we have configuration offer from the controllers, since we have up-to-date image offer from the controller, right? So once they will go and update the image, they will reboot. And once they will get rebooted, again this discovery process, DTLS and joining process will start. So you can see that this reset or reboot is happening once they're joining the fabric, again they are rebooting. Once they are uploading the image, again they are rebooting. Once they are receiving the config file, again they are rebooting, right? So they will reboot 3 to 4 times in SD-WAN as well, because once they are receiving any new update, again they have to authenticate with the controllers that I am the correct guy wants to join the fabric. And this is happening in the same thing happening in the WLC world as well, because this process itself is plug and play process. Okay, any question in this? This you will understand more once we learn SD-WAN plug and play. All right, let's continue. Now you can see this wireless plug and play. The same thing that I have explained you. So today's process, and this is the process I think before plug and play. Yeah, this is the plug and play. So how we are receiving the devices, you can see today's process. Ship the element, the network admin will go and install the OS, config the install config, prime devices, and then they are sending those devices to different sites. In a site, it may be access or distribution or the core layer switch. So direct cost like shipping the devices, then complexity like config problem issues, because you're not following the standardization process. That means you don't have the standard configuration for all the devices, all the location. Whoever network admin is there, as per their knowledge, as per their template, they are configuring the devices and sending to the locations. Third party is not secure. Then manual processes, shipping, storage, traveling, means this is the process that still we are using. But suppose if you use plug and play, then what will happen? That vendor will directly send that device to the branch office. And then the branch engineers simply they have to go and connect to the ISP. And that's it. Once they go and connect to the ISP, then these phases that you are seeing here, these are very much like ZTP process, zero touch provisioning. So obviously you have DHCP server already configured, DNS already configured. Then they will go and form this CAPWAP tunnel or any type of DTLS tunnel in case of SD-WAN or in case of DNA. In DNA also we are using this plug and play. So in DNA lab also I will show you one example related to plug and play. We have lab related to plug and play. In SD-WAN also we have plug and play. Even in data centers also people are using plug and play or ZTP process, right? Then it will go and validate with the vendor as per the networking profile created, and then manual, then it will go and join the fabric. This is very much the plug and play that we are using today. If you have SD-WAN network, if you have this APs, then you can go and use this plug and play feature. Very much this diagram behind the scene. This is actually plug and play. If I go and rename this AP to VEdge and Discovery, Discovery will be there. DTLS slash TLS, join the fabric, reboot, image data config, slash template, run, like that. This is the ZTP process. Now about this string and all, don't worry. I will cover this part in DNA section, because in DNA we are using such type of a string. Everything has meaning, like 5A, 1D, B2, K, J for this HTTP. Then we have something for HTTPS, like that. This string has, I think I have 1 or 2 slides just to explaining that what is meaning of this string and this option 43. Okay, so I'll cover this later. Okay, so now what we have covered, that how this wireless networking is working, the control plane and data plane. This wireless networking, they are using this control plane and data plane, or this SDN concept long back, means maybe 15 years back, they are using this SDN concept, where WLCs, they have to go and form the CAPWAP tunnel with the access points. In this CAPWAP tunnel, we have CAPWAP data tunnel and we have CAPWAP control tunnel. We are using, so these devices, they are using DTLS tunnel for controllers. Oops. But they can go and use the DTLS tunnel for data plane as well. Encryption is optional, but everything is happening within the CAPWAP tunnel. We have full-fledged ZTP or plug and play option in the CAPWAP tunnel. What's the advantage of using this GTP or PNP? So we are saving the operational cost, OPEX, and even we are saving the CAPEX as well. Like, you have benefit in both the places. So we are saving a lot of cost there. Now, one thing I want to highlight here, that if you work in wireless network, such as if you are working in the network security domain, so you are not getting only Cisco devices, right? For example, you are not getting only Cisco ASA firewall or Cisco firepower devices, but you are getting checkpoints, Palo Alto, Fortinet, etc. Now, the basic principles may be same, but again, you have to learn how Palo Alto is working, how checkpoint is working and all. Likewise, if you work in wireless domain, you will not get Cisco APs all the time. You may get Aruba technology. You may get some other vendors as well. Although I can say this, that Aruba is also one of the leader in wireless networking. I think maybe Aruba is #1 and Cisco is #2. But if you are working in wireless networking, basic principles will be same, but different vendors, they have different offering. Maybe Aruba is much more stable than Cisco. Why Cisco is gaining popularity? Because they have introduced iOS XE based controllers, because Cisco has introduced DNA. So that's why they are gaining the popularity. And Cisco wireless APs, WLC, they are also very stable. They are also good product. For security, you can go and integrate Cisco wireless network with Cisco ICE, Identity Services. In Aruba, I think they have introduced something called ClearPass technology. So that's why they are also gaining popularity and they are giving tough competition to Cisco. Cost-wise, maybe Cisco is expensive than the other vendor. So that is also one reason people are looking for other vendors as well. So once you are becoming SME to one particular technology, then you have to check other vendors as well. Okay, so keep that thing in mind. All right, so we have 4 or 5 more slides, but before moving there, if you have any question, please feel free to ask. All right, since this may be new technology, so even I was also not working in wireless, but what happened that I started preparing for CCI wireless. Since I failed that exam, but I learned a lot related to wireless. I was very new to wireless technology. I was not knowing that we have two different type of controllers. We have 3500 or 35XX controller, that is termed as Air OS controllers. Their configuration is very different. You can see this diagram. I have list of controllers in upcoming slide. And then we have 9800 series controllers. Those are very much iOS XE based controllers, right? And those are actually easy to configure, but it's still this 9800 controllers having some bug. Cisco is fixing those bugs. Once that 9800 controllers become stable, you will see that again Cisco will they will become number one in WLC market. Okay, so let me quickly go and try to explain you this diagram, because this diagram you can see is very interesting. You can see that you have a remote site, and this is design related slide. You can see remote site having APs, right? And behind all the wireless network, you should have some wired connection. So you can see that you have APs, and you can see in this remote site, or maybe I have, maybe I have different remote site. Suppose remote site 2, remote site 3, remote site 4. You don't need dedicated WLC to all these locations. Your WLC, you can see that it is in the prime location, A and B, primary and secondary. And from prime location, maybe it is physically located in one location, and these remote sites, they are in different locations. So from this controller, you can see over the WAN, we have this CAPWAP tunnel, right? Over the WAN, we have CAPWAP tunnel, DTLS data, and the control plane tunnels are there. From this tunnel, we are sending the instruction to all these APs. APs will boot and get the configuration, image, everything from this particular controllers over the WAN. Someone has done some big mistake while doing this, you know, I think, and he loses his job as well. So what he has done by mistake, that you can see that the central side, this AP is connected with this edge router, and then it is connected with WAN. So all of a sudden what that guy has done, that in one of his branch having 300 APs, what he has done, that he has booted all the APs in same time, at the same time. And in that case, what will happen, these APs will go and connect to the central location where you have maybe 500 Mbps WAN link. So over 500 Mbps WAN link, you are running other businesses as well, not only this wireless services, but other businesses as well. And all of the sudden, all these 300 APs, they try to get the information and image file from the WLC, and all of a sudden this WAN link gets chopped. So business was shut down for maybe 3 to 4 hours. Later on, they come to know that these APs, they are doing ZTP process, and there are 300, 400 APs. They try to get the configuration and image from the central location, and that's why business was down. So while you are doing this such type of automation and all, make sure that you are not choking the bandwidth from one location, because this is the bottleneck here, this bandwidth. Okay, REST principle, you can understand that, yeah, all the remote location, all the APs will try to boot up and get the configuration. Now in this configuration, you can see this flex mode. I'll not go much detail inside this AP mode, maybe local or flex mode. Flex mode means, in loose term, flex mode means that these APs, you are giving some sort of control as well, some control plane, so they can take their own decision as well if they are in the flex mode. flexible config mode. Right, so this is the design. This is the valid design for the APs, for the WLCs and APs in the remote side. Then I have few slides related to the mobility MSE. So earlier I told you that different components are there. One component is the mobility agent. Now in our CCI lab exam, we have one section, section 3, I think. But this is in CCI wireless, not in CCI enterprise. So we have to go and configure this mobility. And the challenge was this, that we have to go and configure this mobility, entire mobility configuration in CLI mode, like normal CLI, not in GUI. You can go and do the configuration in the GUI. You can go and do the configuration CLI. Like this same machine can work as a AP, same machine or the device can work as a MSE agent as well, but you have to go and change the mode. So once you go and change the mode to the mobility agent, they will boot up, they will get the configuration related to mobility, and then they can work as a mobility device. Now you can see different type of controllers I have listed here. I told you that nature wise there are two. So this mobility express is very much like APs. The normal APs you can convert into the mobility express agent as well. Now you can see the Cisco 350, 550 or virtual WLCs. They are very much Air OS. I think this all are Air OS only. But if you go and see 9800, they are iOS XE based controllers. These are Air OS based controllers. You can see that they can handle up to 3000 or 6000 APs. So it depends that how much APs you want to handle. According to that, you can go and choose the controllers. I think this is little bit older slide. That's why you can see this 5520 is very popular Air OS controller, 5500, and then you can see 8540. This has the highest scalability, but you will see this in those environment, there you have so many access points. Nowadays, it got moved to 9800. Nowadays, customers, they are ordering 9000 series controllers only because they are iOS XE based controllers. Deployments, you can see centralized, flex connect, and mesh, 4 interfaces, power supply, and all. A little bit I have covered here related to mobility control, but you can see that you can go and create the mesh around these mobility agents. Once you go and create the mesh around this mobility agent, this is complete mesh, so they will work as a single system. But yeah, you have to go and it's not like this, it's like this. You have the controllers here, group of controllers, and then you have the mobility agents associated with these controllers. You, you you can think like this. I'll give you one example. You'll understand this, how this mobility thing is working. If you work in data center, we have one device called Nexus 2248 or 2000 series devices. They are termed as a fix fabric extenders. They can extend the fabric, but they don't have the control plane information. For controllers, you need some Nexus 5000 series devices. Like that, this mesh, you can see these devices, they don't have the control plane information, but they are very much looking for control plane information from the parent controllers. And then you can go and do the configuration. Configuration is again easy. You have to go and define the VLANs. You have to go and define the speed, the frequencies like 5 Hz or 2.4 gigahertz, etc. Then it will get configured. So mobility group allows controllers to pair with each other to support seamless roaming. across the controller boundary. We are using this mobility groups just for the roaming purpose, right? And then few slides more, if you want much more roaming, then you can go and group different type of mobility controller groups that is shown in the device. Now this is the last slide for today's session, because this will tell you little bit best practices related to high performance. So you have to go and do the RF planning, RF optimization, radio frequency optimization, high availability planning, and then application and visibility. Now, all these controllers, these WLC controllers, you can go and you can enable AVC, application visibility control. You can go and do the QS, quality of service related configurations. You can go and define the RF. You can go and define the roaming. Everything you can go and define. Apart from that, if you have multiple controllers, you can go and create this SSO. We have discussed about SSO in our previous session, and you can go and create the high availability as well, because as per best practice, we should go and create the high availability and redundancy across the controllers. So we have discussed a lot. If we have any question, please ask. Thanks for joining. We are in day number 10, and today our topic is to understand the multi-cloud networking, SDN related to DNA, and SD-WAN. So those topics I'm going to cover today. Now, before we start, yesterday I shared some software. Please download this software, and you can run in your laptop, or even in your, if you have any server, you can run there as well. I have shared actually two different type of software. In one software, that eVenG file. In one eVenG file, you can do routing and switching. In that, you will see routers and switches. You can build any type of topology. You can run OSPF, BGP, EIGRP, everything we can do in that image that I shared later. And earlier I shared one link that is 13 gig file where you can do routing, switching plus SD-WAN. It's SD-WAN pre-built image. Once you go and run that file, automatically all those devices with pre-config will come. And in the in the second lab that I have shared, one link I have shared, in that I need to share some pre-config as well. You need to do the pre-configuration, and then that particular lab will work. Obviously, I will show you all these things later on.
Okay.
But from your side also, if you want, you can try.
Okay.
All right, so let's start this multi-cloud networking overview. Actually, this is very much like within your enterprise. So we know that we have on-prem networking. Uh, everything was on-prem only. Later on, due to this evolution of clouds, such as Azure, Amazon, Google, they have their own compute infrastructure. They have their own data centers. And as per their data centers, they have developed their own networking. Means cloud is something like pay and go. Whatever services you need, you can take those services from the cloud provider, and as per the services, as per the resource that we want, we can pay, and we can the businesses can run. Now there are pros and cons for this cloud infrastructure. The pros is that it's actually everything is built up. You don't have to build anything from scratch. What you need, just define whatever services you need according to your services. You can go and choose whatever cloud is suitable, and then you can pay and you can use that service. It's like that easy. Now, flip side is this, that if you do not know that how you want to utilize the cloud, so in that case, you have to pay extra. So if someone don't know that, okay, they want to use some compute for 1 hour. After 1 hour, the charges are this.
or maybe they are using that compute for 10 hours and they are not shutting it down after 10 hours. So cloud will go and charge for next 14 hour as well. So it's like that. We should monitor whatever services that we are using, how much we are using. It's like customer job to monitor that. And that's one of the disadvantage, you can say. Lack of knowledge is a disadvantage in the cloud realm. Then apart from that, whoever customer is there, he should go and check that, okay, the same service offered by Google or Amazon or Microsoft, these services, which particular vendor should I go so I can reduce my cost, or which is much more feasible for such services, because a few cloud they are providing services which is better than the other another. And I think you are expert in cloud, so you know all these things, what I'm talking.
Mhm.
Okay, all right. So let's quickly move on here and let's see that this cloud network, what exactly, because here the coverage is just to know from Cisco perspective, just to know that how you can go and connect this cloud. Uh, in SD-WAN also, you will see later on that there is one particular topic called cloud on ramp. That means that we can go and host our CSR or maybe VS, virtual VS devices on different type of cloud platforms. So those are my devices that I am hosting on different type of cloud providers. But those devices I can go and manage from vManage, from SD-WAN vManage GUI. Okay, so that's the thing that you will see later on. Now we know that we don't want the monopoly of single cloud provider, so that's why we have evolution of uh, different type of cloud. So that's why we are in the multi-cloud environment, that we don't want to host all the applications on one single cloud provider. You will see later on we have different diagrams and why we have such design standard. We'll see that.
Mhm.
Now, when we are connecting our network to the cloud, and you can see different links are there, you can go and have a look on that. Let's go, let me show you that extending our on-prem to the private cloud. We have different devices. Cisco has Cisco CSR. You can see this virtual form factor 1000V that we can go and host over any of the cloud. Generally, this CSR 1000V is utilized, or other products are also there, such as Cisco Viptela V-Edge, Virtual Edge. That also we can go and host. So let me quickly go and let me quickly show you different type of architecture with different type of cloud provider. Later on in your study, you can go and check these links. These are very much like doc section for the VPN and dedicated interconnections. All right. So as you know that different clouds, although behind the scene, they are doing same thing, right? So for example, whatever we are telling Microsoft Azure Express route, that is very much same that we have in the Direct Connect, right? That terminology is very much same that we have in the dedicated interconnect, and VPN is everywhere. So point here is this, that my on-prem, so here you can see that private network, and then you have the edge router or the border router. So how you are extending your private network to the cloud? Multiple ways are there, right? You can go and connect your router to the VPN gateway, right? And then you can see that from VPN gateway, we have the cloud routers, and then different resources will start. So this is one of the way that you can go and create the tunnel in between the on-prem to the cloud related to VPN. Then if you have a multiple private network, you can see that we have two different uh, devices. One is ASA firewall and ASR 1000. This is the router. Then still we can go and create the IPsec tunnel with the Google Cloud VPN gateway, right?
Mm-hmm.
Likewise, now you will see the problem here. So now you can see that these devices at the moment we are talking about that we are extending the on-prem network to the cloud infrastructure, where so far in this diagram we have only one cloud provider. But if we are going and mixing with multiple cloud provider, so now you can see that the same edge router or the border router we are extending towards the Google, we are extending towards the AWS, Amazon. Now in both cases you see that icon will get changed, but the concept is same. Either even if I go and connect with Azure as well, you have some VPN gateway router and then you have their own cloud router or VPC router, right? So now again you can see that not only that we can go and create the VPN tunnel, but in between cloud also they can create the networking. So Google Cloud can go and talk with the Amazon, right? AWS. We have one very known technology in Cisco called DMVPN, and later on we have a lab related to this DMVPN. Now you will see the change, right? So last design. So this design and this design. You see this design for a few seconds, and then
Mm-hmm.
I'll go here. Can you tell me what is the difference here in both the designs?
There's a DMVPN, and show me the next, the one before, the one before. Um, the I think there's the DMVPN. There's a difference, and there's an interconnect between the Google Cloud VPN and the AWS VPN itself.
Right.
Okay, no,
So
no, you have this, you have the here you have the Cisco CSR. Mm,
yeah.
yeah.
So
I have it. This
now,
thing they are showing me this next one. Show the next one. I have this task at work that they're asking about how they can form the MVPN. So they can use Cisco CSR to form the DMVPN.
and even
All those clouds that they don't have the DMVPN capabilities, right?
yeah, and even you can
Okay.
see this as well.
Mhm.
So I'll come to these designs. Now we know that okay, we can go and use VPN routers or VPN gateway that different cloud providers are supporting. So Cisco, we can go and use Cisco ASR or Cisco any Cisco border router, and from the vendor perspective, we can go and use the vendor provided router and we can create the tunnel. No problem. This is valid design, but there are some problem in this design. First of all, these devices, they are not built to form DMVPN tunnel and all. Because
Mhm.
DMVPN, you will see that it's very much like Cisco proprietary VPN solution. This is one of the nice VPN solution that Cisco they are providing. And in that, in DMVPN full form is dynamic multi-point VPN. So DMVPN itself is very a scalable solution related to IPsec tunnel. Otherwise, what you have to do, let's suppose if you have 100 sites, in 100 sites, you have to go and create 100 static tunnels if you are not using DMVPN. And then again, branch, suppose this is my hub, for example, and these are my branches, branch 1, branch 2, branch 3, like that if you have. Then if you are not using DMVPN, then this tunnel will not automatically form. This is the property of DMVPN. In DMVPN, we have property, or we have the attributes of DMVPN, that they can go and form a spoke to a spoke. Suppose this is a spoke 1 and this is a spoke 2. So they can go and form dynamic spoke to a spoke tunnel. So in that case, you can go and use the DMVPN solution. But problem here is this, in the previous diagram, that you don't have Cisco routers. So in that case, what we can do, that even in the cloud premises also, we can go and install Cisco instances, Cisco instance routers like CSR 1000B, because they are built to install over the cloud. So complete architecture is like this, that they can easily be installed in the cloud environment. Now we can go and easily do such type of design. But again, the problem here is this, that suppose if you have single point of failure, suppose this is the hub and it is the single point of failure, then in that case, a spoke, so you will see the spoke, they do not have hub. So in that case, what we can do, and this is the valid design, that instead of having one DMVPN hub, in the hub side, we have two different DMVPN hub. One is primary, one is a standby, and then we can go and form the tunnel. And this is the highly scalable, valid design. Okay. And this type of lab we have later on. Only thing is this, that we will do, means all these devices will be the part of our own network. Even in our CCI lab exam, that is very big lab that we have in CCI. In that you
Okay.
have big full-fledged lab where you have your DMVPN in the data center. So hub is in this particular device that you are saying. It is in data center. And then we have two different branches, branch 1 and branch 2, separated by ISP. And in that ISP, we have to go and run MPLS. So we have such lab and we have full-fledged configuration. You have to go and configure phase 1, phase 2. You have to go and enable BGP in between them. Like all those things are there in the lab section. So don't worry, we have full-fledged configuration for this. Okay, so design-wise, you can now understand that how we are moving from multi-cloud VPN gateway router to multi-cloud Cisco routers, and we are forming the DMVPN. This is one of the valid design that customers, they are using it. Okay. So now we'll move next, and then we have to go and learn about different type of controller services related to SD-WAN and DNA. All right, so next topic we have related to SD-WAN. We have, I think, 15 to 16 classes on SD-WAN. Again, don't worry, we have full-fledged classes for SD-WAN related to what is SD-WAN component and so many different labs. Okay, so it is going to come maybe after 2-3 months. We have the SD-WAN and DNA. All right, so do you know Cisco SD-WAN? SD means SDN driven wide area network. We know that
Yes.
SDN is nothing but decoupling of data and control plane, right?
Okay.
Now different components are there. So while we are doing the decentralization of data and control plane, what we are doing, that simply we are taking out the, you can see here the control plane, the management plane, and the orchestration plane from the data plane. So this is my data plane device in the bottom. So we have segregation of data plane, control plane, management plane, and orchestration plane. And then we have different components here. You can see clearly the name of these components. So this is nothing but vBond. What vBond is doing? This is the orchestration plane. If any device or any controller, they want to join the fabric, first they have to go there and do the authentication. So this is authentication server. This VBond is working as an authentication server. He has to do the authentication with respect to serial number, with respect to chassis ID. Then only any of the device will go and join the fabric. Then you can see this management plane. This management plane is nothing but we manage. And this management plane role is like any management plane role is that configuration management, device management, compliance management, like, the real time status, device upgrade, image management, like all sort of management, network management work it can do. Plus, it can go and integrate with the API, third-party API. So later on, when you study more about networking, you will find that now we have got evolved from CLI to GUI to API. Now, either it's a CLI or it's a GUI or API, means with respect to CLI also you can do all sort of configuration, but it is not that much scalable because CLI is something like you are doing configuration box by box. You are logging to the device, you are doing the configuration, logging to the device, doing the configuration. The next phase is GUI. Now CLI based configuration you can do only in router and switches, right? Because router switches, the configuration number of lines are less. But if you go and check security devices such as firepower, such as WSAs like web proxies, such as email security appliances, ESAs, iron pot, maybe F5 load balancers and all, you will see that doing configuration via CLI is not that wise because you have to write 50 lines or maybe 100 lines of configuration in CLI. So that's why those at least security appliances, you don't want to do configuration via CLI. You have to go and use the GUI. But in GUI also you have problem. Until unless you have something called controller. So for example, firepower. In firepower also you have firepower management console where you can create all those configuration and you can push to the FTD, the individual firewalls, right? But still it is not that much scalable and it is not that much fast. That's why we are moving towards the API. API is very much like programmable interfaces where you can go and configure thousands of devices at a time. Thousands of devices you can go and configure with API. Again, this is programming interface. The problem is this, that you should have same type of configuration, right? Otherwise, again, you have to go and log into box by box and write the program in a way that box by box, it will go and do the configuration. So if you have similar type of configuration, it's wise to use API with some programming like Python or Ansible uh, knowledge. You can go and integrate API with the programming language and you can work. Now, all these things from where you can do? You can do from the management plane, right? In this case, we are talking about Cisco SD-WAN, but again, different vendors, they have their own SD-WAN, and different vendors, they have different style of SD-WAN as well, right? I'm sorry. So now, lastly, you can see that you have the control plane. This is vBond, and this is the brain. So all
At
routing,
the top, yes, you mentioned that there's V1 at the top.
yeah, vBond is the authentication server. Oops, my bad. This is VS Smart. Sorry for that. This is VS Smart. You can see here somewhere mentioned. It is not mentioned, but yeah, it is VS Smart. This is V1. This is correct. So VS Smart is the is the brain, and this VS Smart is going to take all the routing decision. You can see the name itself is Smart. So it's very smart. And this small V actually stands for Viptela. Earlier, company called Viptela, they have developed this SD-WAN. Later, Cisco has acquired this company, and now they are managing everything, and they are rebranding as their name. So this is the brain. All the intelligence related to routing, related to policy, related to IPsec, everything resides within the VS Smart. Okay, so you have these components. Now, these are the controller components, right? So orchestration, management, and the control plane. What about these data plane devices? What they are doing? So these data plane devices, actually, the actual data will move from one branch to other branch, right? So these data plane devices called branch edge. Earlier it was called V edge,
VH. Okay.
right? And then Cisco has C edge. So these branch edge devices, either V edge or C edge, they are actually the data plane devices, and in between these data plane devices, we have IPsec tunnel, and those IPsec tunnel, we don't have to do anything. Automatic, at the moment you'll go and bring up the control plane and the data plane, this IPsec tunnel will form. And then you can go and exchange the data, means you can go and send, receive the data in between different branches, right? Now, apart from that, there are different complexity, but overall, these are the controllers and these are the roles of the different control plane devices. You have any doubt in this at this point?
No, not at all.
All right, great. So let's quickly move on. And before going further in this topic, I will go and quickly draw some diagram. Again, you can see that we can go and integrate with the cloud, and it's like anywhere to anywhere. And it's like any transport, any location, any service, any deployment, just like that. So I will go and draw one diagram quickly before moving further. Now, again, you can see this is the summary slide where you will find that you have any transport, you have different branches. Now, we can see that you can go and have your private cloud, like any of the SD-WAN head end side. It may be anywhere in the data center. It may be anywhere in the cloud. You can go and host any application over SaaS, software as a service, right? So it's like anywhere to anywhere service. Now let's quickly go and draw one diagram. Just give me a second. So let's quickly see that what we have in our lab. We have multiple labs related to SD-WAN. In the exam setup, you will find that you have actually only one data center, I think. Yeah. So in the exam setup, you have one data center and you have two branches. Like that we have in our lab as well. We have different type of labs. So first we'll do all this study in our lab setup. Later on we'll see that how it is in the exam. So
Yeah.
you'll find that you have two devices in our lab, two edge devices. And in the branch, one branch we have two devices, and other branch we have one device. And in between, we have two ISP, internet and MPLS based ISPs. So this is our data center. And then you will find that within the cloud itself, we have vSmart, vBond, and vManage. So suppose vManage, vSmart, and vBond. This is my MPLS, and then we have the connections. This is very much that we have in the lab setup. Later on, we'll see this. And then you have one branch with 12 link. Now we will see later on that we have something called T-lock extension. We are extending the control plane with help of LAN. We'll see that later on. And then it has its own LAN. LAN network. Okay, so such type of connectivity you will see actually anywhere in any enterprise network. You have your hidden devices, SD-WAN hidden in the data center, and then different type of branches you have. Now, one variation you will find later on that in the production environment, you have one more device that is there in the cloud environment. So any cloud. And in that cloud, you can go and host your router. And again, this router, it depends that how the connectivity will go. So it can be extended from internet like that. Okay, and obviously behind this router, you have all your cloud related network like VNets or any type of virtual network. Right, so this is the actual diagram. What we have done in this in SD-WAN environment that we have decoupled. So these routers now got decoupled and your controller is at one location. So this is my control plane. And then data plane devices you will see at different locations. Now I'm going to give different color for different connections. So how the connection goes, that obviously you have the MPLS, these connections that you are seeing here. Actually, this is IPsec tunnel. I'm not giving ISP here, but you should have two IS because you have connected with MPLS internet. So you have two tunnel, two IPsec tunnel reaching towards that as well. And obviously here, from here to here also you have IPsec tunnels like this. And then you can see the data center. So from data center to branch also you can see that it's like complete meshing of these data plane tunnels, right? But this is like you have your IPsec tunnels. Now, what about the control plane connection? So yes, you should have the DTLS or TLS connection with the control plane as well. So you will see that there is one other complexity here that you have to go and manage the control plane DTLS tunnels. These are the control plane tunnel. And then you have to go and manage the data. You means that the customers has to go and manage and track the data plane tunnels as well. IPsec full mesh tunnels are there. So those complexity are there in the design, but with those complexity, what we are getting, what advantage we have is this, that we are getting full scalability. So if any tunnel will go down, still you have reachability via some other ISP. So if this will go down, you can go via the MPLS. If tunnel will go down, you can go via the internet to reach this, right? So those benefits are there, but this is highly scalable design. The SD-WAN design is highly scalable design. Okay. Now you will see that in this slide, I have given some notes related to orchestration plane, some slides related to vBond, and then you will see some slide related to vManage. Whatever we have discussed, those things are only there. vManage is there for centralized management, REST API configuration, monitoring management. Then VSmart is there for routing, IPsec, VPN, service chaining, traffic engineering. It's all policies. Then data plane devices are there. Different type of data plane devices. You can see that different types. We have VH, we have CS devices. Now we have Cisco ISR devices as well. Now later on when we'll study this, you will find that there are two different type of operating system. One is Cisco iOS XE and other one is Viptela operating system or SD-WAN operating system, right? So obviously these SD-WAN operating systems are there, which are natively mapped with the SD-WAN features. Because since Cisco has acquired that company, so they try to put everything inside their iOS XE code. But then they found lots of disadvantage. So slowly Cisco, they also moved their devices. So these two devices you can see on top. These devices are running pure SD-WAN code. They are Cisco devices, but they have Viptela operating system. Viptela OS. They don't have iOS XE. Although these devices you can see here in the bottom, they have iOS XE based SD-WAN feature. Okay, so those things are there. But anyways, when we'll go study a little bit more, you will understand. Just for knowledge information purpose, I have given this. Then we have TPM TAM modules. This also we'll discuss later on. Okay, so far you have any question?
Not at all. Not at all.
All right, so now we'll move to DNA. DNA is also big. It's a big topic, and we have full-fledged lab and coverage in upcoming sessions. In DNA, this is like controller-based LAN. So just now we have seen SD-WAN. SD-WAN is nothing but that is controller-based WAN, wide area network. DNA, so two flavors are there in SDN. Actually, three flavors are there in Cisco. One is data center where they are using EPIC controllers or Cisco ACI. Then we have WAN. In WAN, we have Cisco SD-WAN. In that, they are using, just now we have seen vManage, vBond, vSmart, vEdge, and cEdge, these devices. And then we have LAN SDN as well. SD-LAN you can see, say, or we can see DNA, DNAC, Cisco Digital Network Architecture. Inside that, we can see here the SD access. SD access, software defined access, is the LAN automation. And DNAC itself is working as a management plane. And there are different things are there. I will see later on. But roughly at this point of time, you can understand that we have SDN related to data center. We have SDN related to WAN. We have SDN related to LAN as well. Everything we have, for each and everything we have SDN defined, right? So let's quickly go and see this SD-LAN. Anyways, we have full-fledged, again I told you, full-fledged SDN topic, the DNA topic coming on later. So now if you see these slides, you will get very much, like overwhelmed virtualization, automation, analytic, cloud service, API and all. Cisco will put everything in one slide. But point here is this, that yes,
I have a
DNA,
question though, real
yeah,
quick.
please.
The ACI, what's the use of the ACI?
ACI is data center automation. This is application centric infrastructure,
Mhm.
ACI. Yeah, so ACI
So
data center, in data center, you have leaf spine architecture where you have Nexus switches, where your LAN, then you have your compute devices, where you are connecting your um, compute devices such as VMware virtualization and all. So let me quickly explain you this. So Let me quickly draw one data center architecture. You will understand what does it mean.
Okay.
So when you are talking about enterprise networking, any company like Vodafone, Xerox, Epson, Canon, HP, any company, maybe SAP, Microsoft, Google, any company. So they have different locations, different branches, and then they have their servers like Facebook. Facebook may have their server somewhere, right? Or YouTube. YouTube, they may have server maybe in US, in Mumbai, in other locations as well. So what they are doing that their services, server where the services, means servers where they will run, there are some services, right? So
Mhm.
those services should be secure. Otherwise, any hacker can go and hack and ask for ransomware and other things. So nowadays, whatever company you will see, they have something called leaf spine architecture based data center. So what does it mean? That they have the spine connected with the leaf. And here I am drawing only three. So this is our network part. This is pure Nexus switch or maybe Brocade or maybe HP or maybe any vendor leaf spine architecture. Now this is our switches. Now these switches, they will go and connect. So you will see that these switches will go and connect. Let me go and draw here two portions. Just for sake of simplicity, I am drawing only two more box, but later on you will understand. So this can go and connect. Oops. This can go and connect with, suppose this red one, red link is the storage, maybe NetApp or maybe Dell boxes, any type of box. And then let me go and use this green color. This may be server. So this may be UCS server. UCS is server virtualization where you can go and connect with the storage, for example, NetApp. Okay, so one box is a storage box. One box is the server box. A storage means where you are storing everything, database and this and that and all those things. And server means that you will go and run up the server. You can write the application. You can create your backend, and then your front end maybe any web application, web server, right? So you can see here that everything is connected with our data center backbone. This is my switch's backbone. This is the data center.
So what you're saying now that the ACA now, if we connect our, let's say our spine is the core, then
This
the leaf. If we connect
fine.
this, if we connect this leaf, we can use ACI to configure it automatically.
Yeah, so now what we are doing, where we are connecting ACI is this, that all these leaves, they have one connection, will go to one other server, and this server is nothing but one management box, which is known as Epic controllers, right? And from Epic controller, you can go and manage the leaf and spine configuration, the stats, upgrades, everything you can manage from Epic. And this entire architecture, leaf spine plus Epic, is nothing but ACI infra. Got it?
Yes.
Great.
Wait, hold on a minute. So let me ask a question. This Epic, right?
Hmm.
That's the ACI. That's the automation side of it.
Yeah.
Okay.
Means you can do automation as well from Epic, but you
Hmm.
can do configuration via CLI as well. You can do via GUI as well. All three options are there.
Okay.
Okay. Great. So now you can see this digital network architecture. So whatever options you are seeing here, this is related to DNA, related to LAN. Same thing you can do from ACI to DC. So within the ACI, you can do automation, you can do analytics. You have to go and integrate some analytic engine. You can go and do some sort of virtualization. Yes, you can do, because the Epic controllers, you can connect with VMware, Kubernetes, any container like that, any which physical workload, any virtual workload, everything you can do. Nowadays, yes, ACI is also cloud enabled and DNA is also cloud enabled. They have open and programmable. They have a standard base. Yes. In analytic, you can go and do the network data and contextual insights. In automation, you can go and do the full automation. They are open with the API. They can have the developer environment. It can go and do the policy orchestration. Network enabled applications are there. Means whatever you're seeing inside automation, security, compliance, each and everything you can do from the Epic controller, but in data center. And this is related to DNA in LAN.
Okay.
Okay. All right. So that's the capability, that's the power we have with the with the SDN. SDN is not only enabling the capability to manage the devices from one location, but you can automate the devices from one place as well. So it is opening one area related to automation as well, and obviously cloud integration as well. So at the moment, if we go and discuss three main areas, you will find that one area is automation, one area is cloud integration, and one area is SDN management. So three key areas are there nowadays. One is the cloud integration, how we go and integrate your network to the cloud. Then you will see that you have automation, and then you will see that you have the SDN based management, managing the device from the single location. That is also one key area. Right, and in all those slide, you will see that automation, virtualization is also one key area. How much we can go and virtualize. Then design evolution and network based applications. Everything we can go and integrate with the new SDN controllers. Right. So next we have very important topic related to fabric and the other very important topic related to DNA that I will not cover today because we have very less audience. Hi everyone, thanks for joining. We are in day number 11 and today we are going to learn about fabric. You will see that there are so many misconceptions related to fabric. What is fabric, why we have fabric and all. And then we'll move and we'll go and learn about quality of service. Quality of service is one of the big topic that we have because we know that we have different type of QoS. Different types means that we have software-based quality of service, we have hardware-based quality of service. And for different platforms, you will see that the QoS, how we are applying QoS is different. For example, how we are applying QoS to Nexus devices versus how we are applying QoS to normal devices, both are different. Normal devices means normal switches, iOS XE switches, both are different. So let's learn one by one all these things, that how this QoS we can go and apply. And first of all, let's start with the fabric. So when we are talking about fabric, what do you understand with that term fabric? Do you know the meaning of fabric? Yeah, you know
Um,
what is fabric?
is it like a cluster or like things that are connected together?
Fabric, things connecting together. Any other definition?
Mm. As in, it
Any
says
other
mesh of connections between network devices.
Okay, so what's the meaning of fabric? Connection, maybe it is physical, maybe it is maybe virtual or something, but what's the meaning of fabric? Okay, so let's take this example. Think about LAN, normal LAN connection, and you have one requirement that you have to go and separate different type of services in LAN. For example, you have three different VLAN. You have data VLAN, you have management VLAN, and you may have some other VLAN like guest VLAN, thing like that. Or you may have VoIP related VLAN. So let's take this example that I have requirement of 3 VLAN, and each VLAN you are putting 10 different PC. 10 different PCs you are putting. So how you will go and design the network? You got my point. So there is one small network issue, networking design you have to do, where you have to go and put 3 VLAN, and in each VLAN you have to put 10 PCs. How you will go and design? What you will do? It's very easy, right? What you
Mhm.
will do, you will take one switch, right? In that switch, so 3 VLAN and 10 PC. So you will take one switch that should have minimum 30 ports, right? And then in that switch, you will go and divide that switch into 3 different parts. Like one portion, you have 10 interfaces where you will go and put one VLAN, suppose VLAN 10. Then other part you will go and add 20, remaining 20 ports, and you will put in VLAN 20. Then other part you will go and put 30 remaining ports, and you will put in other VLAN, for example, VLAN 30. These VLANs are data VLAN, maybe management VLAN, maybe guest VLAN. Like that, you will go and design the switch, right? And then what you will do, that you will go and connect the PCs. So 10 PCs you will go and connect. 10 PCs you will go and connect. 10 PCs you will go and connect. And then you will go and configure the access port related to VLAN 10, 20, and 30, right? Any doubt in this?
Not at all.
No doubt, right? Now, this is very a small network. You are telling this is a LAN network. But the problem here is this, that suppose if VLAN 10 PC wants to communicate with VLAN 20, it's not easy, right? How they will communicate, because VLAN 10 having different IP subnet and VLAN 20 may have different IP subnet. So in that case, what you need to do, that either these switches will be intelligent enough to do routing within the switch itself, or If these switches are not that intelligent, then you will go and connect one router. So in that case, what you will do, you will go and connect one router, and in that router, you will go and define a network. So in this router, in this interface, you will go and define sub interfaces. And in this sub interfaces, suppose this is E0/0. So you will go to router E0/0.10, E0/0.20, E0/0.30, and you will go and define the gateway. Suppose one is 3.1, other is maybe 2.1, and first one is maybe 10.1.1.1. These gateways you will define. So what will happen when VLAN 10 wants to communicate with VLAN 20, then they will go to the router, check the gateway, and then they will go to the other side. Right? You will do like this. Any doubt in this? You are able to understand this?
This is another way to do it, right?
Yeah.
Yeah, okay.
One of the way, or maybe you will go and do this arrangement in the switch itself if it is a layer 3 switch, like
Mm-hmm.
high-end switch. So within switch, you will create SVIs. In that SVI, you will go and define the gateways. And within SVI, they will go and do the routing within the switch itself. Right? Okay. So think like this, that this is one of the customer. Suppose this is customer A. Likewise, same requirement you have with customer B, customer C, customer D, customer A. You have 4 more customers where you have to go and do the same arrangement. That means you don't want to touch the physical cables, like whatever connection you have done with the same connection, you have to go and separate the data management and guest VLAN for next 4 customers, B, C, D, and E. How you will do?
Say that again.
Yeah. So the thing that we have done is the requirement was related to customer A. So we have customer A. For that, we have separated the data VLAN, management VLAN, and guest VLAN. Now the question here is this, that you have to do the same arrangement for 4 more customers, 4 different customer B, C, D, and E. The same thing you have to do, and you are not allowed to touch the physical connectivity. So here you will see that you have some physical connections as well, right? What physical connections you have? Router to switch, switch to PC. Without touching this physical connectivity, how you will go and do the same arrangement with the rest of the customers?
Uh, are you gonna have another switch, or you just find you use a switch that has a bigger model that has um that you can configure other VLANs in there.
Other VLANs we can configure, right?
Mm-hmm.
Great. But there are some problems here in this, that this is only 30 port switch, for example.
So what we'll do is like we in my office we have a core switch. The core switch has all the SVIs on it. Then you have access layers, which is connected to the core switch.
VLAN gateway limit. Now, the IPs that you are using, the gateways you are using, it's difficult to use those gateway, those IP for other customers. You can use, no problem, because they are independent customers. So same IP schema you can use. So there is no problem. You can use that IP, but there is problem with this switch. In this switch, you have only 32 ports or maybe 48 ports. Then there will be the limit, right? Okay, I will give you the answer. You're going right. Now, think this situation as a cloud provider. So think this arrangement, this is a small cloud. One router and one switch is a cloud. Now, customer, they are coming with one requirement, the same requirement that we have with customer A. Now, customer B also have the same requirement. How the cloud provider will do this? So as you know, that cloud is nothing but someone else's data center. What they are doing, they are expecting that these many demands will come, right? So that's why when they will go and deploy their services, instead of having only 48 port switch, what they will do, that they will go and add more switches in the stack. So what they will do, that they will do the stacking of 4 switches or 5 switches. So that means the interfaces in these switches will become, for example, 30 into 4.
That's
30 into
120.
4, that means 120, right? So with this, they can easily go and serve customer A, customer B, customer C, customer D, right? A, B, C, D, they can go and easily provide that solution that we are talking about customer A. And the point here is this, that with this arrangement, that whatever arrangement that they will do for us, with this arrangement, and they are stack switches. With this arrangement, they do not need to go and change the hardware connectivity. What they will do, simply they will go and do some software configuration. Some logical thing will get changed. You got this point? Any doubt up to this point?
No.
Now let's understand this fabric. If you understand this, you will understand the fabric. So what is fabric? Fabric is network virtualization. That means you have some fixed network connectivity. On top of that fixed network connectivity, whenever you are doing any logical changes or logical or software configuration, that is fabric. Okay, so far so good, right? This definition of fabric. So what I'm trying to tell here is this, that for example, LAN. So when we are talking about LAN network, local area network, or CAN, campus area fabric, so we know that we have access switches, right? Now these access switches, they are connecting with the distribution switch, and this distribution switch is connected with the core switch. Like we have 3-tier architecture. So in this 3-tier architecture, Let me go and connect all the interfaces. So in this 3-tier architecture, you're defining that what is your core, what is your distribution, and what is your access. Access 1, access 2, access 3. Oops. This is access 3 and access 4. Point here is this, that if you are thinking this is your campus area network, these are the access switches, campus area network, then you have to go and define different type of roles to different type of switches. Roles, and those roles are defined within the fabric. So this may be your control, or what we can say, control or border node. This may be your this may be your control as well, or transit node. And these where you are connecting the PCs, they are your edge nodes. All these access nodes, all these access nodes are your edge nodes, where because you are connecting the PCs or laptops or end system. Now this arrangement, when you are doing this arrangement within the this arrangement that you are doing within the campus area network or the LAN, so this entire system, whatever control, border, transit nodes, edge nodes are there, the entire system, the physical connectivity, the hardware connectivity, you are doing one time, right? You are not doing this hardware connectivity changes every day. And then you are defining the rules over the devices. So all these devices that we have in the list, they are part of fabric, right? They are part of fabric. So tomorrow, if we have some requirement, right? Tomorrow, if we have some requirement, then you are not doing changes in the hardware level, means you are not doing any interface level changes, but you are doing the changes in the software level, in the configuration part. You will do changes. Those configuration, they are nothing but the virtual networking or network virtualization. Network virtualization is termed as a fabric. Either it's a LAN, or it's a WAN, or it's a data center. In all these three places, we have definition of fabric. So this is LAN fabric, then you have WAN fabric, then you have data center fabric, right? Any doubts so far? You're able to follow?
Mm-hmm.
If no, then let's see the slides.
Yes. Yeah, it's going good.
So now you will see in this diagram, you will understand now very easily. So now you will see in this diagram that you have some physical connectivity in the bottom. Things are connected in the blue cable. Now this physical connectivity is one arrangement, which is your hardware connectivity. But on top of that, if you go and create any type of logical networking, like this switch, and this switch, they are part of maybe same LISP or OTV or DFA or ACI data center automation, OTV or DFA or LISP. So then this will be the fabric, and fabric is termed as a overlay. This is your, this physical connectivity is your underlay, and on top of that, your fabric is your overlay. So you may have layer 2 overlay, you may have layer 3 overlay. Overlay is virtual networking or logical separation. So again, you can see in the diagram, you have physical connectivity, and then you have overlay transport or overlay connectivity. Overlays are nothing but virtual networking or fabric. Again, you can see that you have overlay control plane in the red, and then you have the data plane. Layer 2 overlay examples, layer 3 overlay examples. Layer 2 overlay examples, maybe you have OTV, or maybe I think I should have some examples of layer 2 and layer 3. You can see that there are a list of layer 2 plus layer 3. So GRE is your layer 3, OTV is your layer 2, LISP is your layer 3, ACI is your layer 3, IPsec is your layer 3, MPLS is layer maybe 2.5. So you may have layer 2 overlay, you may have layer 3 overlay. For example, VLAN, that just now we have discussed about VLAN. You know that VLAN, right? So you have one giant switch. In that switch, you can go and divide this switch in logical separation for VLAN 10, VLAN 20, VLAN 30, VLAN 40, like that. And then you can go and map some ports within these VLANs. So few of the ports, they are belonging to VLAN 10, few of the ports belonging to VLAN 20, few ports belonging to 40, and the rest belonging to default VLAN. Right? And we know that these are the logical separation. So VLAN is also type of overlay network, right? Anything that we are segregating from the physical connectivity, that will become part of overlay, part of fabric also, you can say. So far, any doubt?
No.
Great. Now, we have to learn about different overlay technology in our SGN study. So we have two different topics in our CCI enterprise. One is Cisco DNA and one is Cisco SD-WAN. The other thing, that is ACI, is part of CCI data center. That is data center overlay technology or data center SDN technology, right? Now let's focus on the content that we have in our curriculum, that is DNA, Cisco DNA. Later on, you will see that we have full-fledged session for DNA, but in DNA, because we are studying about overlay technology, so let's quickly discuss that what type of mechanism we have related to fabric in Cisco DNA. So you can see that we have a LISP-based control plane, a VXLAN-based data plane, and then we have TrustSec, that is nothing but the policy plane. So you have control plane, data plane, and policy plane. Policy plane means that DNA you have to go and integrate with ICE, Cisco ICE, where it will go and provide you the policy framework. So let me quickly see that if I have any diagram where I can go and show you all those things in single. I don't have single diagram. So before going any further, let me quickly draw one diagram so you will understand what I am telling. So suppose you have giant big fabric in this black circle, and in this I will go and draw some of the routers. Let me go and change the color to, so suppose you have one router here, one router here, one router here, and then you have some other routers in green, and then you have some switches in the bottom. Later on, you will understand that this definition of these devices. So this may be my control, what we can say, control plane router or control router. You will understand later. I'll explain. This is my border router. And then this green, they are nothing but the transit devices. We are not defining any role. They are in between the fabric. This complete black circle, this black circle is nothing but the one fabric. And then these switches that we have in the bottom, They are nothing but the edge nodes. Edge nodes. So what I'm telling here is this. These are the edge nodes. Edge nodes, they are the edge devices. So point here is this, that in one fabric, you have to go and define, first of all, you will do the physical connectivity. Once you do that, then you will go and define the fabric role. So these are the fabric role. Why this is control? Because here you have to go and define the routing control plane, that is LISP, locator ID separation protocol. Why this is border? Because from here you can go out in, means you can go to the other sites or you can go to the internet. So this is your border router. You are defining this as a border router. So go out, come in, learn different type of prefixes, subnets and all. And then your edge nodes. Why? Because they are connected with the devices where you are applying the TrustSec policy and all other different policy that is coming from the ICE. Now this complete fabric, they are connected with the management plane, and your management plane is Cisco DNA. Then this complete fabric, they are connected with the policy plane, and your policy plane is nothing but Cisco ICE, Identity Services Engine. And they are sitting in the management plane. So now in this diagram itself, you will see that you have something called management plane. You have something called policy plane. This is nothing but your policy plane. Then you will see that you have the control plane. Then you will see that across the devices, the edge devices that you will see here, if it is a SDA fabric, so these devices, they are forming some dynamic tunnel within the fabric. Those dynamic tunnels, they are termed as a VXLAN tunnels. In ACI term, we are telling that these as a VXLAN tunnel endpoint, VTEPs. So these edge devices, they will go and assign the role of VTEPs, VXLAN tunnel endpoints. Here also you can term this as a VTEPs as well. And everything, whatever things that you're seeing here, the Cisco DNA, Cisco ICE, the border, the control plane, the transit devices, the edge nodes and everything is a part of one fabric. Right. Again, the point here is this, that everything is part of one fabric. You have done one time connectivity connection, but later on, if you have to do any policy change, any other requirement for different customer or different business unit within same customer or same premises, you can go and do it easily because you have that big giant framework where you can go and do any logical changes. Right. So knowing this thing, and everything is recorded as well, you can go back in the recording and see what I'm telling. Now you can go and quickly understand. LISP is the control plane, VXLAN is data plane between edge to edge devices, and then you have the policy plane. So you can see control edge border, an intermediate node where we have non-LISP forwarder. Then you have fabric domain, virtual network is nothing but your fabric, endpoint, IDs, host pool. These are the terms, obviously you will understand in the STA. What is LISP? Locator and ID separation protocol. It is that which is creating the control mechanism. Very much it is working like DNS, which has the information for all the endpoints. So what LISP is doing is they are collecting two information. Let me quickly show you that. So in any routing table, if you go and see, you will find that you have two different information. One information that is your own connected interface, any router. They have the information about connected interfaces, and other information that they have, they are learning from other routers. So these routers, whatever routing table they have, they will advertise. And then this router, with help of any routing protocol such as RIP, OSP, or BGP, whatever, they will go and learn. So they have their own network, and then they are learning some network from other router. They have their own network, and then they are learning from some other places. Own network, and then they are learning from other places. And that's why you will see in the diagram itself that we have two type of arrangement here. One is the topology route, one is the endpoint route. Endpoint route means my own connected network. Topology route means I am learning from some other place. Okay. Now the IP address, you will see that it has a location and it has identity. Again, you will understand this is a bigger statement. Any IP address you are seeing here. For example, I'll go and write one IP address. For example, 10.10.10.10. This is one of the host IP, right? So you think like this, that you have one PC. In this PC, you are assigning one IP, right? So in this PC, you can go and assign IP address 10.10.10. For example, 10.10.10.101, right? You can go and assign this address to this particular laptop or this particular PC. Any doubt on this? No doubt, right? We can do this. But in this 10, suppose 0/24 is different thing, and 10.10.10.1, so 2 up to 10.10.10.254. Even starting from 1 as well. There are two parts, right? You're able to understand what I'm telling? So what I'm telling that in a IP address, you have two different type of thing. One is network information, one is host information. So what is your network part? This is your network part, right? Routers, what they will do? They will send this information. But what IP you are assigning to the host part? There's the endpoint routes. So you can see the endpoint routes. This PC, what IP that you will assign? You will go and assign in this pool, right? Maybe .1, .2, .3, .4, etc. So routers, they have understanding of both different type of routes. Now here you can see example of 3 routers. Suppose if we go and connect 100 routers, what will happen? Isn't this particular information will grow drastically? And all the routers, irrespective of that, these routers, they have to go and forward those information to these IP addresses as a destination. Still they have to go and memorize these big routing tables. Is it necessary? So what LISP is doing, that these information, instead of sending to all the routers, they are decoupling the routing table. So with help of LISP is a technology and it's an old technology. What LISP will do, we can see here in the diagram, is that all those network information you can go and put in some database. It's not like Oracle or SQL database, but it's a router. Within router, you'll go and define the role related to MS and MR, I think master router or master controller, etc., where they have all these informations, and these routers, they have only host route information. So the point here is this, that suppose this router wants to go to this location and he don't have the information, what he will do? He will go and do the query to the LISP master, and then LISP master will tell, okay, now this is your source and this is the destination. You don't have that destination. Take this destination. I am your DNS server. This is the destination you are looking for, and learn only that particular route to reach to this particular location. Now, this is one of the important enhancement to protect the control plane, and this is huge. Lisp is so popular, you will see that so many different service providers, they are using Lisp. Now, this Lisp configuration you will not see in normal enterprise. Maybe in your enterprise you are not using Lisp, but Lisp is very old protocol and mature protocol, and different ISPs, they are using Lisp to scale their control plane, routing control information. Okay, so this is how that within DNA. So once we are learning DNA, and within DNA we have one topic called SD access, software defined access. This Lisp configuration we have to do. But good thing here is this. So what are the configuration you have to do in DNA? You know, in DNA, in SD access, we have to configure VXLAN, we have to configure LISP, we have to configure any underlay protocol, maybe OSPF, ISIS, and then we have to configure BGP. The good thing about this that you don't need to go and configure these protocols and anything. You don't need to go and configure this. Cisco DNA will automatically configure everything for us. So Cisco DNA, what we have to do, we have to go and do the deployment from the GUI. Once you go and do the deployment from the GUI to the devices, for example, defining the control border, edge devices. Once you go and assign the role, automatically DNA will push the Lisp configuration, VXLAN configuration, underlay, and BGP configuration. Everything Cisco DNA, all the CLI configurations Cisco DNA will do for us. We don't have to go and do any configuration related to all these technologies, but all these technologies are there in Cisco ST Access. Lisp is there, VXLAN is there, TrustSec also you can do from Cisco DNA. Okay, any doubt in this so far? It's actually very difficult to understand in single day, but don't worry, we have the classes, we have extended classes later on, but at least you should understand that what is fabric, what is underlay, what is overlay. Fabric is a big term, right? Fabric is a big term. It's a logical networking or virtualization where different customers you can serve with same infrastructure. That's the whole goal of Fabric. It's like very much cloud oriented um, methodology. In cloud also, we don't know that what is happening within the cloud, and cloud can serve different customers. Like that, Fabric can do the same thing that cloud can do. It
Okay,
can.
just a quick one. Just a quick one. You said with the Lisp um protocol, right?
Yeah.
I think the key, well, from what I'm looking at your PowerPoint, the key two things are the what's it called, route locators and the endpoint identifier.
R-lock and T-lock, two things are there.
Yeah, yeah. So you have your mapping system. That mapping system, is it like a database or a router?
That marking system,
The mapping system, because you have it here. I'm looking at it in I think it's slide 132.
which slide you're talking?
132. 132 in your week 2. Yeah, 132. Yeah, this one right here.
This one?
Yeah, this one. Yeah. So you have your mapping system. You say you have your endpoint identifier and you have your routing locator. So is this mapping system, the mapping system, is it like a database or is it just like a router or is it virtual?
Okay, so you will see these devices, these switches in the diagram. You can see all these blue switches.
Yeah, endpoint
These switches, they are
identity.
connected with the PCs or laptop, right?
Mhm.
So that means that they are access switches or they are the edge nodes. Now these edge nodes, they will give the information about the host. Host information you will get from these edge nodes, right? So that's why these are the endpoint identifier. And then what we are doing actually, this is nothing but one router or pool of router in
Mhm.
between. What we are doing, we are providing something called loopback addresses to these devices. These loopback addresses are becoming the RLOC, router locator. So how the LISP system will come to know that how to reach to these edge nodes, edge devices, they are using this loopback addresses as a router locators, RLOCs, to reach them. So that's why they are able to reach. So what will happen tomorrow, that suppose if there is one requirement that this EID wants to communicate to this EID. Now, these devices, they do not have full routing table. They don't know how to reach from this location to this location. So, because you have the router locator, so he can query here and he can also query here, and he has all the database. Because he has the reachability, he has the EID information for all the devices, and plus he has the router location, means how to reach to the router to all the edge nodes. So now they will go and do the query to the locator, and then locator will tell how to reach to the other endpoint, right? You got that?
Yes. I guess.
Like very much like DNS system, how DNS is working.
Okay.
Eric, you have any doubt?
No, I'm following. I think it's yeah, maybe the first time, so I'm trying to understand everything.
It's like identity and location. So identity means this IP and location means how to reach it. And then if they don't have the reachability, they will go and do the query to the LISP router. In LISP, where we have defined the LISP master and LISP backup devices. And then according to that, the forwarding will happen. Now, again, these slides are very detailed. You can see that control plane. So what is the role of the control plane device? Then the edge nodes. This control plane is nothing but your LISP control plane. And then you will see this two clouds here. They are actually going to outside. So you will find these are the border planes, border devices. Later on, you see the naming. Bottom one is the edge, so you can see border. Overall, the role of device is this, like this is the control. These are the border and these are the edge. You will see later on in Cisco DNA that they are defined as a E, edge nodes, and they are defined as a C. C, so isn't like a control pin cannot become border, cannot become edge. Suppose if you have only one control plane and border, so it may have dual role as well. Suppose in your fabric you have one control, one border, and only one edge, so it can become triple role as well. And suppose if it is a wireless controller as well, so it will become W as well. So one device can become CB control, border, oops, border, edge, and wireless WLC as well, like that. The role can be defined, but better that you separate the roles for better network design and troubleshooting. So different devices, they are doing different jobs. right? Like that, you have all these slides. Now in these slides, there is one more level of difficulty, that how this SG ACLs they are working. I will not go and cover at this moment because it will become too complicated to understand. But yeah, you can see that's the virtualization. You have different virtual networks. So this is the fabric, right? I told you that this is one of the fabric where different customers, you can go and provide different services. So if it is one giant single fabric, and if you do not go and divide this fabric in different virtual network, then it will never serve that purpose, right? Because you have only one big logical network. So in that logical network, you have to go and define different type of virtual network. Otherwise, it will never provide different services to different customers. And that's right, we can go and create different virtual network. Like you can go and define networking for employees, networking for guests, networking for IoT, networking for uh, maybe other thing like contractor. So what we are doing practically, like in the exam also, you'll find that we will go and define virtual network for employees, virtual network for contractor, virtual network for guest, virtual network for IoT, virtual network for maybe wireless. Like that, you have to go and define the network. Why you are defining the network, different virtual network? Because if you have a small virtual network, then you can go and control that network. Then you can go and create different policies for different virtual network. Right, so you will get the full control if you have virtual network segregation. So likewise, you will see in these slides that we have the virtual network. And again, I have defined the list. If you want to learn more about LISP, you can go and have a look. Then VXLAN header. This is again little bit difficult topic, but I will cover this VXLAN later on. Because we know that in the SD access, the VXLAN is working as a data plane. So how it is, how the packet format, we'll discuss this later on, don't worry. Then how this encapsulation and decapsulation is happening, how this VXLAN data format is happening, and VXLAN is something like IP in UDP or UDP in IP. Encapsulation, you will see that you have the VXLAN header and then you have the UDP header. So VXLAN is coming with UDP. This is the normal original packet. Right, in this normal original packet, if you are doing encapsulation with LISP, so you will see that LISP header. And then if you are doing the data plane packet forwarding, so you can see that VXLAN. So you have the VXLAN, but VXLAN is coming with the UDP header as well. And that's why you will see here in this diagram that in this format, you have VXLAN, and then you will see that UDP header. And this UDP header, actually VXLAN will give you 50 bytes of extra header, extra overhead for the header. And you will see that you have outer IP header. In this outer IP header, you have source and destination RLOC information in the outer. So you have the internal payload, MAC, and IP. On top of that, you are putting extra header information for VXLAN, UDP, and the LISP RLOC, source and destination. Like that, uh, from one place to other place, the movement will happen. Earlier in this today's session, I told you that we have something called VTEP. VTEP is nothing but VXLAN tunnel endpoint. And then you have the next hop, because whenever you deliver the packet, it will go deliver to the MAC address and the final destination address. So that's why in the outer header, you will see that you have the outer destination MAC, and then you have some encapsulation related to VXLAN. Actually, this is encapsulation related to destination.
Okay, and clearly you will see that in this diagram we have segregation of overlay and underlay. Right. This is one of the diagram. It will take at least 25 to 30 minutes to understand this particular header format and everything. Because in this packet format we have everything. We have concept of VXLAN, we have concept of LISP, we have concept of SGT. Everything you will find here in this diagram. So from your side, you try to understand this, and later on we'll do one full-fledged session just for VXLAN. One complete one day, 1 hour or 1 hour 15-20 minutes for VXLAN. So we'll understand more about this VXLAN. Okay, don't worry about that. But at the moment, at least you should point out two things, that it will go and give you 50 bytes of extra overhead, and VXLAN is coming with a UDP header whose port number is 4789. These things, these 2-3 points, you can put in your memory list, because generally these questions people are asking in interview, that once you have the VXLAN header, what's the size of the VXLAN header, what's the port number, UDP port number, and then what other informations we have. Later on we'll go and discuss. Now this VXLAN is different than the ACI VXLAN. There you will see the port number is different and other informations are different. Why we are using VXLAN? What's the use of this? Again, we'll discuss later on. Okay. All right. And again, just for your information, that how this packet format look like. While creating these documents, I took too much time to create these documents. These documents will help you in your future study as well. All these PPT and slide I already shared with you, and these things are actually very important. For your knowledge perspective, for your troubleshooting purpose perspective, it will help you. Protocol 17 means what? UDP, right? Protocol 6 is TCP. This is 17. And then you can see the destination port. Then you can see the source routing locator, R locator, destination routing locator. This is the outer header. Then underlay, overlay header is what? Your VXLAN header, where you have the VXLAN network identifier, VNI. Then you have the reserve bit RRR, IRRR. They're the VXLAN reserve bits, and then inner header. Inner header, we know that we have payload, source MAC, destination MAC, source IP, destination IP. Then you have this VXLAN header, and then you have this outer header, where actually the actual destination information will be. Right. What devices we have? Supported devices. We have the list of supported devices, the Catalyst 6K, ASR, Nexus 9K, etc. And then finally, we have one full-fledged diagram that will tell you that how all those things will fit in one diagram. This will be the last diagram for today's session. Let me quickly highlight this thing. So we know that the role. We know that these are the edge devices. I have explained you about this. Then you have something called intermediate or transit devices that are also within the fabric, but we are not defining any role in this. Then you have the border nodes. Border nodes will take you to outside world. So if you go and read the border node, this is for L3 connectivity. Then you have this control plane where you will go and define LISP services. So you can see the map system, MS, MR, where you will go and define the LISP configuration. Then you have identity services, which is your ICE. Where is the ICE? You will see the ICE. This is working as a policy plane. Then you have the DNA. DNA can work as an automation engine, can work as an assurance engine, can work as a management plane. So it will work like that. Then you have the edge nodes. I already highlighted the edge nodes in our earlier sessions. Then you have the wireless controllers, because DNA is one shop, you can say that, for wired and wireless.
It will provide you both wireless and wireless, wired and wireless services over the same fabric. Okay, so that's why you can see that you have the WLC controller, means wireless controller, and then you have the control plane for the wired networking, and then you have the edge devices. And these edge devices, in this diagram you're not seeing any APs, but you may have APs here and there that will work as a wireless access point. Right, so knowing these things, we can go and stop here. Later on, in the next session, we'll go and start the QoS, because QoS is itself a very big, vast topic. And I have shared one ebook as well in the WhatsApp related to QoS. So my suggestion is this, that please go and watch yesterday and today's video if you missed yesterday class, because both the sessions, both the classes, we have covered about this very, very, you can say that's complicated technologies. If anything new, if you're learning anything new, it will become complicated if you do not know each and everything in that technology. And these technologies have so many different parts and pieces to understand. Okay, so check this document and watch the recording. You will understand at least 60-70% of all these terminologies. Hello everyone, I'm going to give you offer related to CCIE lab. In this lab, what you will find, so let me quickly show you that. In this lab, you have multiples switches. You can see you have more than 16 switches, 20 routers. You have SD-WAN full-fledged lab. Actually, this is complete CCIE Enterprise 1.0 lab, where you can do section 1, section 2, section 3. Maybe you know that in CCIE exam, you have 3 different sections. Means already sections are defined, but generally these 3 sections that students are practicing. And in this 3 sections, you can perform everything, all the tasks you can perform in this particular EVE-NG lab. You can see the version and the supported images. This is exact match that we have in the exam as well. So for example, for SD-WAN, you need to work on vEdges and the vManage. Release is 18.4. That's the same release we have in the exam as well. So this will be your very much similar lab setup that you have in your CCIE exam for your practice purpose. Now, what you can't do in this lab, you can't do lab related to DNA, because in this EVE-NG lab, we don't have Cisco DNA integration, and you can't do ICE lab as well, because in this we don't have ICE integration as well. For that practice, you need full-fledged online rake from any good place. You can go and have it. But apart from that, apart from 2.1, 2.2, actually, you can go and perform all the tasks. Even if you are not practicing for your CCIE exam, for example, you are practicing for your CCNP and you want to check your OSPF knowledge, BGP knowledge, MPLS knowledge, SD-WAN knowledge, all those tasks you can go and perform in this lab. With this lab, I'm providing the video guide, how to do all those tasks. Even we have the lab guide as well. So you can simply follow those guide. You can simply go and complete all those tasks. Suppose if you are new to the technology, so I have multiple free videos in YouTube and Udemy that you can go and refer to upskill your knowledge, to learn the technology, and then simply you can go and use this particular lab and you can break any CCNP, CCIE exam. Means you will pass it easily. Now, what is the cost? And these are the sections that we have in the CCIE exam. So what is the cost of this? Because I'm offering this for the students, so I put very little a small cost here. So you have to pay only 150 USD to get this particular software. And how you can go and get it, you have to email me. So my email address, you can send me one email request.
Let me write here, Ratnesh 721 Kumar 721 @gmail.com. Just email me and send me the request, and I will give you this particular nice software, full-fledged software, EVNG software, or the file where you can go and practice your CCNA, CCNP, CCI, SD-WAN, full-fledged SD-WAN is there. So if you can go and watch my YouTube videos, in YouTube I have 22 hours SD-WAN video recording file, and so many SD-WAN videos I have uploaded in YouTube. Those YouTube videos also, you need some lab setup, right, to practice. So even if you're not preparing for your CCNP or CCI, simply you want to learn Cisco SD-WAN, you can go watch my free videos in YouTube, use this particular lab setup, and you can perform your SD-WAN. You can become master in the SD-WAN. Likewise, if you're preparing for CCNP, and CCNP, again, we know that we have N-core and one elective. For that also, you can go and perform all the tasks related to routing and switching, OSPF, BGP, everything in this lab. It's a full-fledged lab. So I will recommend you to send this email right away. Take this particular lab, practice, enhance your skill, and become very good in the market, so you will get high paid salaries. All right. After that, you go and watch the technology video. Thanks for watching.